Hello and welcome to the modules of Advanced R. In these modules, in the first 7 modules, we are going to discuss some of the recapitulatory ideas of basic R, what we might have come across in the course of basic R as well. From the 8th module, we will come across the advanced programming techniques that R offers us, like object-oriented programming, meta-programming, functional programming and many more. After that, we will show you some of the basic ideas of simulation in R, and as we go along, we will let you know some of the advanced simulation techniques. As we go along, the topics will become a bit harder. In this particular module, we will let you know some of the basic aspects of R, how to download R, how to use it, how to call datasets and many more. So, let's see how we can proceed in this module.
So, the first question which is roaming around our mind is why R? That means, why do we need R? The obvious question is R is open source and free, but this is not the only thing. Along with this, some other advantages are also there, like R contains a large number of highly sophisticated packages which makes life easier. With the help of these packages, you can avoid writing your own program, and hence by giving a minimal effort, you can get your desired outcome. The next thing is a number of hyperactive R communities are always there for your help. Suppose you are trying to write down a program, and in the midst of writing, suppose you find yourself lost within the program and you are stuck with a problem which you are unable to solve at your own. Don't worry, R is always there to help you out in this regard. Just Google your problem. You might find that somebody else might have faced this problem before as well, and he might have posted a solution for it. So, your problem is solved. Here we have the names of some of these communities like R Help, Mailing List, Stack Overflow, R Bloggers and many more. Apart from this, if you want to have help from other languages, then also I will give you that opportunity. A number of languages like C, C++, Fortran can be connected with R. These are really some good advantages. But nobody is perfect, so how can R be an exception to it? It also has some imperfections and disadvantages. Here it is worthy to mention that R comes with absolutely no warranty, and codes that are written without proper care can be very slow at times. So, this is a primary overview of R. Now, let's start using it. For using it, you need to download it at first. You can download the latest version of R from the Comprehensive R Archive Network, which is also known as CRAN. That is also the maintainer of R. You can find them at this address. Now, a number of operating systems are there that we use. You can download and use R in each of them. At the top of the page of CRAN website, there are links to download R for Windows, Mac operating system and Linux. So, we have downloaded R. Now, you know that R has a number of datasets within it. You can see the list as well at a glance within R. But if you want to import data that is already saved somewhere in your system, then you need to use read.csv, and then you need to write down this argument that has been given here. The first one is the structure of the function, and the next one is an example of it. Here we have some of the file extensions that can be called within R. Now, let's find what are the different data types in R. That is, what are the data types that R can understand? Primarily, we have data types like scalars, vectors that include all the types like numerical, character, logical, and then data frame, list, matrix, and arrays. So, primarily we have these kinds of data types, and within the vectors we have numerical, character, and logical. Now, let us elaborate each of them one by one. Firstly, consider a vector. We all know what is a vector, but this is how R looks at the vectors. At first, the numeric one. Here x is a vector of 5 elements containing the numbers 1 to 5, and it is denoted using the command. You know that you might also write down 1:5 here as well within the first bracket to denote x. Both of them will give you the same results. Y is a character vector with these 3 elements, and these elements are written down within double quotes, and obviously they are separated by commas. The next is the logical vector, which contains true and false only. So, if you type x, R will give you this, and if you want to identify an element of or elements from the vector, then you need to use the third bracket like what we have given here. The first one is for the first element, and the second one is for the first 3 consecutive elements. You can see this from the code. This is how we can add or delete elements of a vector. Here we are using the older x to make a new x vector whose first 3 elements are same as that of the earlier x. Fourth element is 4, and fifth one is the fourth element of the previous x. So, altogether our new x looks like 1, 2, 3, and then the 2 consecutive 4s. The next type of data type that we are going to discuss is data frame. It is indeed an important one. Let us see how important it is. The interesting part of it is that each column in a data frame can hold a different type of data, but within a column each element must be of the same type. In case of matrices, all the columns should be of the same types. Let us consider an example. Here x and z are numeric vectors and y is the character one. Now, what we do is we are naming the columns as age, sex, and rank, and then putting all these different types of vectors within the data frame using the data.frame command. So, this is how my data frame looks like. Now, let us see how we can find the details of the data frame. That is, what functions will give us the details of the data frame. The nrow function will give us the number of rows of the data frame. Similarly, ncol will give us the column number of the data frame, and if you want these two, that is the dimension of the data frame altogether, then use the function dim, which will give you the dimension of the data frame, which is named as my data frame. Now, how do you know what are the column names of the data frame? We have given the names beforehand, right? So, now we are wanting to extract the column names of the data frame. So, what do we do? Use the names function and then have it. Here, as we know, the column names are age, sex, and rank. We know this beforehand because we named it. So, how to find the name of any of the columns particularly? Use the column number within the third bracket along with the previous code, and you will have the desired output. Like here, we are having the name of the third column as rank. The row names function will give you the names corresponding to each of the rows. The head and tail function will give you the first and last part of it. The examples are given in these two slides. The head and tail function will give you the first and last part of it. The examples are given in these two slides. The class function will give you the data type. Like here, we know that my data frame is a data frame because we have constructed it like this. The element corresponding to the third row and second column is female with two levels like male and female. So, in the output, this is showing here. Now, suppose you want to take the second and third column out of the data frame. So, what will you do? Type this command. Use the space for the row, leave the space for the row blank. That is, we are not specifying any particular row. We are taking up all the rows and we are fixing the second and third column. So, we are writing 2:3 in the space designated for the columns. Similarly, one can take out the vectors corresponding to sex and rank as well using this command. In particular, to have a particular column, just by specifying the column name, use this command, and by using the drop is equal to false command, one can have the output of this format. The similar kind of output can be obtained by specifying the column number as well instead of specifying the column name, and the output will look like this. So, both of these are basically the same. The objective is to extract a column or a row out of the data frame. So, this is how it acts. Now, this function data will give us series of data sets available in package data sets arranged alphabetically. Now, suppose we are looking at the Irish data set which is there within R, and specifically we are wanting to know the class of the data type. It's an inbuilt data set. So, unlike here, we do not know what is the class of the data set. So, let us see what is the class of the data set called Irish. So, here we know which function to use, and hence we are using the class function. We know this beforehand, and we are having the output as data.frame. That is, the Irish data set is basically a data frame. So, have a look at the Irish data set. This is indeed a data frame. We can conclude it from the structure as well, as it contains data regarding the sepal length, petal length, sepal width and petal width, together with the name of the three species, that is Iris setosa, Iris versicolor and Iris virginica. We can go on experimenting with a number of data frames that R gives us, like tooth growth and US arrest data sets. Use the class function for this experimentation for knowing the data types of these sets. Here we are introducing the next data type, which is list. It can store any number of items of any type. It can contain all numerics or characters or a mix of the two data frames or other lists. Actually, it can contain anything. Just have a list with 3 elements, and here we are having this using the list function. The next one is the single element list, where the only element is a vector 1, 2, 3. Now here we are trying to do an interesting thing. We have already made my data frame just a while ago. Now along with the existing one, we are trying to include a numeric vector that contains the numbers 1 to 10. Now we can't include it within the data frame because the column heading would differ, column numbers would differ then. I mean the column lengths will differ then. So what do? Put them inside a list instead, and here we are having this output. The next data type is a matrix. This is the syntax of it, and you know that you can also find this by typing a question mark then matrix. Here data is a list of elements in the matrix, and n-col and n-row denote the dimension of the matrix. We had come across it previously as well. By row specifies how the matrix is to be filled. By row is equal to false means by default the matrix will be filled column by column. The elements of the matrix will be taken column by column. Here we have a sequence of numbers in the form of a vector, and we are trying to put this row wise in a matrix, within a matrix A with this command. Here we are putting the elements of X within the matrix A column wise. So these are basically the different matrix representation. The basic function is the same, and the question is how to put the elements which you are wanting to put within the matrix. We can also get similar matrix by only specifying the number of rows as 3 and columns to be 2 in the n-col and n-row options arguments. So this is what the output is. Now as we know, dim gives the dimension of a matrix, and cbind and rbind are two useful matrix functions for appending matrices together. Now what we are doing is we are trying to attach one more column with the A matrix. We can do this because the vector x that we are trying to tag along is of length 3, which equals the column length of A, and we are constructing the B matrix by using the column bind function. So now our B is a 3 cross 3 matrix. In the previous case we were unable to attach the vector within the data frame because the length differs, but here we can always do that due to the equality of the vector lengths. Now we are having another matrix of dimension 3, and we are trying to tag it with B row wise. So we are using this row bind command and having the new matrix D. Now as the matrices have been made, the question is how to assess the elements of a matrix. We know how to assess the elements of vectors and data frames. We have come across this before. Here we are using basically the similar ideas in case of matrices as well. To assess any element, just specify the row and column number like the one we have specified here. To assess any specified row, just specify the row number in the first position, and for assessing an entire column, specify the column number only. Have a look at the examples that have been given here. Here we are specifying matrices A and B with the help of the matrix function. Now we are concentrating on some of the matrix operations. Let us consider transpose of A to start with. You need to use T of A, T then within first bracket capital A, that is the A matrix that we have just input to get this. Again, by just writing down A plus B, you will be having element wise addition of two matrices. Again, A minus B will give you the element wise subtraction. You can also add or subtract a particular scalar quantity from all the elements of a matrix. To get a matrix multiplication, use the code that have been given here. Just using asterisk won't solve the problem. So, you need to use the code that have been given here. Det of A will give the determinant of a matrix. So, these are basically some of the matrix operations that have been given here. Inverse of a non-singular matrix can be obtained by using the solve function. Remember, it should be a non-singular matrix. For a singular matrix, we need to use some different functions, because in that case that would be G inverse. Now, we will be discussing the last member of the data types, which is an array. Unlike the previous ones, an array in R can have 1, 2 or more dimensions. It is simply a vector stored with additional attributes giving the dimensions and optionally names for those dimensions. Now, this dimension will be specified using dim, like we have seen this before as well, and the names of those dimensions will be specified using dim names, that is dimension names. So, we can understand that two-dimensional array is the same thing as a matrix. You can have the general syntax using question mark array. By using this, you can have the general syntax, how to use, how to get special kinds of an array and many more things. We have also given a general structure here as well. Just look at it. Here we are generating a 3 cross 3 array by using the array function and then specifying the elements and the dimension. This 3 cross 2 array I contains the index set. Like here, AI extracts the elements A13, A22 and A31. And what are the elements? We know, basically we know the matrix A beforehand. Now only we are specifying the index set. So, from the index set we are going back to the original set, and hence we are having the output like 7, 5 and 3. Next, here we are having a 3-dimensional array, and this is how it looks like.
So, as we can see, in this module we can have a number of basic ideas of using R, like how we can download R from CRAN, why do we need R, why do we need loops, and how to call data sets which are not there in R but which is there in your system. In the later parts of the presentation, we come to know the different data types that R offers us, like vectors, matrices, list, data frames and some others. With the help of several examples, we come to know all these things. In the later modules as well, we will go on the discussion of this recapitulation of basic R, and in those presentations we will let you know some of the basic aspects of the apply, lapply functions, basic loops in R, basic conditional statements in R and many more. So, let us stop here and let us see what is there in the next module.